Ignition sequence starts.
Good morning and welcome to Mission Control Houston. You've got a live view of the International Space Station Flight Control Room and the Orbit 2 team of flight controllers, now monitoring the station's systems and helping the Expedition 60 crew members with their maintenance and science work. This busy week on orbit has been highlighted by visiting vehicle operations, as one of the commercial cargo vehicles wrapped up its mission at the station so it could begin another mission in another orbit, launching even more satellites into space.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Leah Cheshire. The space station freed up one more parking spot this week with the departure of Northrop Grumman's Cygnus spacecraft. After 109 days aboard the space station, Cygnus completed its 11th commercial resupply mission and was released by NASA's Hague. Upon its arrival on April 19th, Cygnus delivered nearly 7,600 pounds of research and supplies to the orbiting laboratory, including experiments studying vascular aging in astronauts, a tool to more easily analyze biological samples in space, and a few free-flying robots called Astrobee. Though Cygnus is no longer attached to the space station, its work is not finished yet. Once Cygnus reaches a safe distance and higher altitude from the station, it will use the slingshot deployer to eject a series of nanosatellites. It will also be evaluated by an external, free-flying robot called Seeker. Seeker will take images of Cygnus and perform attitude maneuvers to demonstrate its ability to operate safely around another spacecraft. Afterward, it will be commanded toward a disposal trajectory, leaving it to burn upon re-entry to Earth's atmosphere. After a few more months of system tests, Cygnus will also be destroyed upon atmospheric re-entry. This week's question is from Alex M., who asks if Cygnus can boost the space station before it returns to Earth. As Alex noted, some spacecraft have the capability to boost the space station or raise its altitude while still attached. This keeps the space station from having to use its limited fuel supply to stay in orbit at about 250 miles above Earth. Cygnus has been tested for and can provide a boost to the space station if required, but most altitude adjustments are made by the Russian Progress spacecraft or by firing the thrusters on the Russian service module Zvezda. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
The astronauts and cosmonauts who serve on board the International Space Station spend their days taking care of the spaceship and assisting scientists on the ground with research in a wide range of scientific disciplines. They're working on experiments that can enable future space exploration and experiments that can have an impact for those of us here on Earth. Early this year, ESA astronaut Alexander Gerst worked on an experiment with a particular protein crystal that may hold important insights in the treatment and prevention of Parkinson's disease, which affects more than 5 million people. NASA astronaut Serena Aughnan-Chancellor walks us through what that was like.
Welcome to Expedition 57 on board the International Space Station. Today we're doing some really cool science. This is Alex Gerst over here with me, and we are working on Parkinson's disease. What we're looking at here is a special protein kinase, or protein crystal structure. And the reason scientists have sent it up here to the International Space Station is because these protein crystals tend to grow larger and of much better quality. Parkinson's is a disease that affects over 5 million people worldwide, and scientists are constantly searching for a cure. And what we discovered was that here in the microgravity environment, these crystals really like to grow. So if scientists can better elucidate or clarify the structure, then they're better able to develop an inhibitor drug for Parkinson's. And not only an inhibitor drug, but an inhibitor drug with very few side effects. So what Alex is doing here today is he's obviously working on the wall, is what it seems like here in microgravity, and he is. He's got a microscope above him, and he's got a plate that he filled with this special protein crystal structure just a few days ago. Gave time for those structures to crystallize, and now he's examining them under the microscope. And he's actually interacting real time with the principal investigator on the ground to look at the crystal structure, to help improve the lighting and the clarity, and then also take pictures, which will then be sent back down to the ground. So here on board Expedition 57, we're very proud to be taking part in this experiment. I think in the past few years, scientists have realized that the microgravity environment is such a unique environment to grow things like cells or protein crystals, and it provides a new way to help us look at diseases in a better way, to help us develop new medications for these diseases, and so we're happy to be taking part in the science up here.
There are several studies underway on the International Space Station designed to help get human beings ready for future missions, like Artemis program missions back to the moon, and after that, missions out into the solar system. Scientists are busy exploring ways to provide those astronauts with the nutrition they'll need to stay healthy when the time comes for them to leave the home planet on journeys that will last for years.
A successful mission starts with nutrition. Presented by Science at NASA. Centuries ago, large wooden ships explored the seven seas. But often a ship that began its voyage with a crew of hundreds could return with tens. The silent killer? Scurvy. A disease that occurs when there's a lack of vitamin C in the diet. On the other extreme, explorers of the North and South Poles could fall ill by eating the liver of polar bears and seals, exposing them to toxic levels of vitamin A. Centuries of exploration have taught us there is a vital relationship between a successful exploration mission and balanced nutrition. And nowhere is that lesson more vital than in the extreme vastness of outer space. NASA nutritionist and manager for nutritional biochemistry Scott M. Smith, Ph.D. notes, "We're studying nutrition aboard the International Space Station, or ISS, by tracking what astronauts eat and how their body mass and health change over time in microgravity. Menus that lack variety and busy schedules can impact the astronauts' dietary intake, and insufficient intake leads to weight or mass loss, bone and muscle loss, cardiovascular effects, and more. The foods on ISS are all shelf-stable. There is no refrigerator or freezer for food. Right now, we're lucky because we're able to deliver fresh fruits and vegetables to the station. But think about the first human trip to Mars and back, which may take 30 months or more. How do we maintain optimal nutrition for our astronauts over that much time? The challenge is clear. In space, the astronauts' environment impacts their nutritional needs. Astronauts have higher radiation exposure, higher atmospheric levels of carbon dioxide, low humidity, and microgravity, which can all have effects on their health. Having a balanced, nutritious diet is important to help counteract spaceflight effects on the body. These can have short-term consequences, like on mood and performance and kidney stone risk, and raises long-term concerns such as bone and muscle loss, cardiovascular degradation, impairment of the immune function, and vision changes. Smith says the foods we give them will be of utmost importance for counteracting these effects, which is why we need to find ways to keep the food palatable, nutritious, and safe, even after it's stored for months or years. Keeping an eye on intake will be important too. Currently on ISS, astronauts use an iPad app to track intake, and this gives them real-time information on their diet. The nutrition team and flight surgeons also watch this information to help provide feedback to astronauts. This attention to astronaut nutrition is also paying dividends for those on Earth. Smith notes that astronauts on board the space station have already delivered a plethora of nutritional data that can be applied to all people. He says we've gained new insights into how nutrition can have effects on all human systems, including dietary effects on bone loss, which affects the elderly in particular, and how to better treat that condition and others. Of course, says Smith, a simple start for people on Earth to maintain optimal health is the same as it's been for centuries. Keep eating your fruits and veggies. For more science from the International Space Station, go to www.nasa.gov/ISS-science. For more appetizing information about space exploration, visit science.nasa.gov.
The International Space Station has given us more than 20 years of scientific research and been a platform to test and perfect a new fleet of vehicles. The knowledge we continue to gain from this orbiting laboratory is vital to our future in space.
The International Space Station, a football field-sized, million-pound laboratory flying around planet Earth at 17,500 miles per hour. It's our home in low Earth orbit and the bridge to exploring the far reaches of our solar system. A place to learn what it takes to live, to work, to thrive in space. Thanks to space agencies representing more than a dozen countries around the world, it went from the drawing board to liftoff when the first piece flew into space in 1998. That kicked off over a decade of construction, hauling the station to orbit piece by piece on NASA's space shuttle and Russian rockets. And after the first crew arrived in November 2000, we started an unbroken streak of humans living and working in space. Building on the legacy of past outposts like Skylab and Mir, the International Space Station became the training ground for humanity's next great journeys. Learning how to live in space for extreme periods of time, building and perfecting the technologies necessary to travel to our neighbors in the solar system. It gave us a place right on our doorstep to prepare for the next giant leap into the unknown. And thanks to the station, a new era in outer space is unfolding. What was once the domain of only nations and governments is now populated by a growing space fleet from American industry. Private spacecraft to fly cargo and crew members, new habitats and technologies for future space missions, and an open door for companies, research institutions, and even students around the world to do research in space that have never had the opportunity before. All laying the foundation for a robust economy in space. There have been thousands of experiments, hundreds of spacewalks, endless hours of challenges and successes, all done by humans hailing from countries around the globe. The International Space Station is what we can achieve as a planet when we come together to do the things that are hard. And the work isn't slowing down, because we're ready for the next giant leap. Because we're ready to go farther. Because what we do and learn along the way is for the benefit of all of humankind.
The International Space Station has more internal space than a 6-bedroom house. That's contained within a vehicle that's large enough that it would cover an American football field. So how long does it take to get a tour? Not as long as you might think. In this Speedy Time feature, astronaut Jack Fisher flies us through the station from bow to stern in just 3 minutes and 18 seconds.
Today we're going to take a tour of the incredible place we get to call home, the International Space Station. We're starting in the JLP, which is one of our mini closets for stowage. Then we're coming in to the Japanese segment. We have lots of experiments. We have huge freezers that you've seen. Then we have a node where we can dock modules in 3 different directions. We have the European module called the Columbus. It has tons of scientific equipment as well. This thing is called Mares. It's one of the biggest things on the station. All right, let's check out the United States Laboratory. But first, we'll see where we sleep. This is node 2. We watch our movies here, and we sleep here. This is where I sleep. It's pretty messy, but at least there's a flag. That's cool. In here is the United States Laboratory, the Destiny. We have tons of equipment in here, not only scientific equipment to look at different experiments, but also some of the systems that really keep the space station going. So that's pretty cool. We also, in here, have node 1. We can dock more vehicles here at the docking port. On the bottom, it gets kind of confusing what's up and down. In here, we have the airlock. This is where we get into our spacesuits in this room, and then we go into this little room, and we close the door, we take all the air out, and we go outside and do spacewalks. Very cool. Over here, we have our treadmill, which you have seen before. Right here, we have our toilet, the super space toilet, or outhouse, as we lovingly call it. We have the A-Red, which you've seen before from Peggy's video. This is the PMM, where we store a ton of stuff. And then, of course, everyone's favorite, the cupola. If we come down here, you can see outside, and it's gorgeous. It's just so pretty. It never gets old. Okay, let's check out the Russian segment. Come on, here we go. We're going through the little hatchway that takes you into the Russian segment. Inside the Russian segment, there's lots of modules as well. Down here is Mimadin. This is one of the many places where we dock vehicles. This is where Peggy actually docked. This is FKB. This is another place where we keep a lot of our storage. It also has some of the critical systems for the Russian segment. Over here, we can go one of two directions, and it sometimes gets confusing. Let's see where we're going home. This is Mim Deva. We have an extra spacesuit, and we have our spaceship, the beloved Argo. So you can see we have 3 little pigs in a blanket with our spacesuits, and then this is our actual spускаемый аппарат. That's what we sit in, and that's the part that we actually land in. This part actually burns up in the atmosphere. Okay, let's check out the heart and soul of the Russian segment, the service module. Obviously, the service module holds lots of critical systems for the Russian segment, but also for the space station, like our engines, to reboost and get to a higher orbit if something's about to hit us. One of the cool things that's in the Russian segment is the Russian cosmonauts, like Fyodor, our commander. In the Russian segment, we have tons of great windows. These are really high-quality windows, so we can take pictures. We also have a lot of systems that keep the station going, and we have another cargo vehicle at the very end of the station. And the last thing I'm going to show you is my favorite space picture because of what it represents. This is Yuri Gagarin with a dove, because space is a peaceful exploration where we work together. If you notice, I got a Russian shirt, I got American socks. It's international. That's what this place is about, working together as one team. Woo! That's Speedy time this week. Have a good day.
During their time on the International Space Station, many astronauts have the opportunity to participate in spacewalks, which are critically important in keeping the station functioning properly to support the science activities that go on inside and outside the vehicle. In this demonstration video, astronaut Ricky Arnold gives us a tour of the critical parts of the space suit that keep astronauts safe as they perform maintenance in the harsh environment surrounding the space station.
So we are standing in the Quest airlock, which is divided into 2 parts. We have the equipment lock and we have the crew lock. This equipment lock has a hatch right here that closes, and the crew lock has another hatch. The EMU, or the Extravehicular Mobility Unit, is our spacesuit, and it's divided roughly into 2 parts. We have the hard upper torso, which is almost like a turtle shell. It's a hard fiberglass shell, and then we also have the lower torso assembly. These spacesuits are our own little spacecraft, and they have everything you need to keep you alive out in space for 7 to 8 hours, maybe even longer, depending on how hard you're working. The only thing that they do not have, and they have radios, it has oxygen, it has carbon dioxide scrubbing, it has temperature control, it has everything you need except for one thing, a restroom. And so when we get ready for our EVA, the first thing we put on in the morning is a diaper, and that's our first layer. Then over the diaper we put on a pair of long johns, and that's to keep our arms and legs from getting scraped up. It also provides a little bit of wicking in case you're getting really hot and sweaty. The next layer is our liquid cooling garment, and the LCVG has little tubes running through it which allow water to circulate inside the LCVG to provide cooling when we're outside working really hard. So we've got the diaper, we got long johns, we got the LCVG, and then we're going to wear our spacesuit. 7 layers from the bladder on the inside, which maintains pressure, and that's a rubberized bladder, all the way out to the white layer on the outside. The crew member inside the spacesuit is also wearing this, what we call a Snoopy cap. It's a communications cap. We have a radio, so we can talk to not only to Houston, but we can talk to people on the space station and to each other. So we wear this communication cap inside the helmet. Also another key component of the EMU, or a spacesuit, is the helmet. You can see the helmet has a gold visor which protects us from the rays of the sun that we can bring down. It's pretty bright out there, and this gold visor helps reflect the rays of the sun so we can actually see and operate in daylight. At nighttime, we can raise this visor up, gives us a clearer view, and additionally we have helmet lights built into the helmet. On top of the helmet, we also have a television camera, so the ground is able to watch us while we work through these TV cameras. The work is really all done with hands, and
So our gloves are really our most important piece of equipment in order for us to work outside. And one of the real challenges of a spacewalk is you have this heavy gloved hand, which is inflated. So it wants to stay like it's blown up like a balloon. But we walk by grabbing onto handrails and making our way along the ISS. So every time you move your hand, you're fighting against a balloon that wants to inflate. And then on top of that, all of our equipment is based on using your hands too. So after 6.5, 7 hours of kind of fighting against this glove, it's a really long day, and your hands are probably the thing that are most exhausted after 7 hours out on an EVA. Well, we're going out to work. You probably saw me move this mini workstation. The way we carry our tools is on a mini workstation, which is carried on the front. Every single tool we use is tethered to us. We do not want to accidentally create satellites. Our primary way of remaining attached to the ISS, if we're not using our hands, are these waist tethers. And you can see they just have a big hook. They go around a rail or anything else on the ISS and latch on, and it actually has a locking mechanism as well to hold us nice and tight. So we always want to have one of these attached if we're not holding on with our hands as well. The back of the EMU has our life support system. The life support system contains all the equipment we need, from a UHF radio down to the oxygen tanks that provide primary oxygen. One of the challenges inside this sealed environment, it's very easy to carry our own oxygen with us, but we generate a lot of carbon dioxide, particularly when we're out there working very hard. So to combat that, and to deal with that, we have these canisters called Medox canisters, which are just silver oxide. They are carried in the backpack along with a very large battery, which provides all the electricity for us. I don't have a battery here to show you today because we're in the process of charging them. We're about a month out from doing a spacewalk, and we've already started getting ready for that. So this Medox canister is able to remove about 7 to 8 hours of carbon dioxide that a human can generate inside the spacesuit. EVAs have allowed us to build and maintain the ISS, repair mission-critical hardware, investigate malfunctions, install new hardware, and the view, unbelievable. See you next time.
In all of the work being done outside and inside the vehicle, the International Space Station is helping us know what it will take to make successful journeys out into the solar system someday, to Mars and other destinations. Here are a few more examples of how the station is building the missions of the future.
So you want to go to Mars. How does NASA's International Space Station help us extend human presence into deep space? In the future, when astronauts land on Mars, it will be thanks to some important lessons that we learned on the International Space Station. Rewind. 240 miles above the Earth, the International Space Station is where we currently live and work in space. Here's what we've learned so far. First, there's taking care of our astronauts. Prolonged weightlessness can lead to muscle and bone loss, vision changes, balance, and coordination loss. Thanks to the space station, countermeasures are being developed to keep astronauts healthy for long-duration missions. Then there's the equipment. Spacecraft communication, water recycling, air, and power production are all being test-driven on the International Space Station. What we learn about operating and maintaining our gear in the harshness of space will pave the way for future missions into our solar system. And that's how the space station is helping us extend human presence into deep space. For more information, visit this NASA website.
Expedition 60 flight engineer Nick Hague was the first member of the 2013 astronaut class to fly in space. He got there just a few months ahead of his classmates Anne McClain and Christina Cook. But Hague is quick to say that his 2 space flights, like everything else he's done in his life, are the result of a team effort.
I grew up in western Kansas, and I love figuring out how things work. When I was young, I liked breaking things and putting them back together. My entry into aviation started as a flight test engineer. I was an engineer working in a laboratory designing satellite systems and was accepted into the Air Force Test Pilot School. But I think that the amazing experience was just the breadth of airframes that I was able to explore and to test out. Everything from the most complicated fighters that we have out there to home-built aircraft. And that diversity of exposure really scratched my engineering itch to really get an understanding of what aviation's about. So my wife and I are both graduates of the Air Force Academy. The Air Force is the only way we would have ever met. My wife is from New York, I'm from Kansas. Our paths would have never crossed, so we owe everything to the Air Force and the Air Force Academy for bringing us together. We're both in service. We're both committed to serving our country. But more importantly, I think it's committed to serving something larger than ourselves. It's all about teamwork. Every assignment I've had, I've been part of a team. And that idea of you're going to be reliant on the people around you for success and defining your success not on your accomplishments, but on the team accomplishments, that's something that Air Force instilled in me and gave me the opportunity to grow and refine. Human space exploration is the ultimate team sport. We're going to have a team of 6 people on orbit for my expeditions. We've got a team of over 100,000 people on the ground that are supporting us on a daily basis. You don't do these things individually. There's no success that's gained individually in space exploration. It's all about the team. I'm Colonel Nick Hague, and I'm a NASA astronaut.
If you'd like to get another look at any of the stories we featured today, and you might, check us out here on YouTube and on Facebook. You can find everything we ran today, plus you get a look at a lot of other cool stuff you can find there about NASA and America's human spaceflight program. And while you're out there bumping around on the interwebs, check out Houston We Have a Podcast. That's folks here at NASA talking about their work in all aspects of space exploration. We post new episodes every Friday. Today, Gary Jordan learns about how the Orion spacecraft is designed to help its human crew members deal with emergencies when he talks with Orion Crew Systems Integration Lead Jason Hutt. Go to nasa.gov/podcasts for today's episode. In fact, all of our previous episodes. You will also find the full library of all the NASA podcasts right there, all of which you can also listen to on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.
And look on space to ground 2, it's okay if the switch stays on position.
So currently it's on the on position. Should I turn it on the OSS position or not?
Negative. It can stay as it is. And look on space to ground 2, negative, the switch can stay in off position, OFF.